All right, let's jump right in. We're going to talk about software security today, but I want you to forget about lines of code for a minute. Instead, think about blueprints. Seriously, every single app you use, every website you visit, it's a structure, right? And the big question we're asking today is, are we actually building these things to be safe from the get-go?
So, for what feels like forever, the industry had this really simple and, let's be honest, pretty dangerous philosophy. It was basically build it, ship it, and then, well, wait for somebody to find a crack. Security was a total afterthought. It was just a patch you'd slap on after the damage was done. This whole reactive mess was known as penetrate and patch, and yeah, it turned out to be a complete recipe for disaster.
And the consequences of this build first, secure later model, they became painfully clear and fast. The early 2000s, they were just this endless, exhausting cycle of vulnerabilities and emergency fixes. You might remember Microsoft's infamous Patch Tuesday. But then, the real wake-up call started coming. In 2002, Bill Gates sends out this landmark trustworthy computing memo, basically demanding a massive culture shift. And even way later, in 2014, we get the Heartbleed bug, which showed everyone just how fragile things were, exposing critical data all over the web. It was obvious. The old way was fundamentally broken.
And honestly, this quote from Bill Gates, it was an earthquake. I mean, think about it. For the very first time, one of the most powerful people in tech just flat out declared that security wasn't just another feature you could balance against a deadline. No, it had to be the top priority. And just like that, the penetrate and patch model was officially dead. The search for a better way to build software had finally begun. Which, of course, brings us to the solution, the security blueprint. See, instead of treating security like a quick coat of paint you slap on at the end, this whole new approach is about designing safety into the very structure of the software, right from day one. It's the difference between constantly patching a leaky roof and designing a house that's waterproof from the foundation up. It's a total game changer.
Okay, so this new blueprint, it has a formal name, the Secure Software Lifecycle. And the key idea is right there in the name, really. It's a formal process that integrates security into, and this is the important part, every single phase of development. It is not a checklist you run through at the end. It's a continuous mindset, from the moment an idea is born all the way to when a product is retired.
This comparison here really captures that fundamental shift in thinking, doesn't it? The old way was reactive. It was chaotic and, man, was it expensive. You were just always putting out fires. This new approach, the secure software lifecycle, it's proactive. Security is now a core requirement. The goal completely shifts from frantically patching bugs to systematically preventing them from ever happening in the first place. So how does this blueprint actually work in practice? Well, it happens in a few key stages. First up, secure design. This is crucial. Before a single line of code gets written, you're analyzing risks, kind of like an architect designing a bank vault. Next is secure coding. This is where developers use best practices and tools to stamp out common flaws as they're writing the code. Then, stage 3, security testing. We're talking rigorous tests to find vulnerabilities before release. This includes things like SAST, which is static testing, basically checking the code while it's sitting still, and DAST, or dynamic testing, which tests the code while it's running. And finally, you have an incident response plan, because let's be real, no system is perfect. You need a plan for when, not if, a new threat pops up after launch. But here's the thing, right? A blueprint for a massive skyscraper is going to look very different from the blueprint for a small house. And it's the same idea here. The core principles of the secure software lifecycle are universal, for sure. But the specific plan, that has to be adapted for all the different kinds of digital structures we're building and the unique challenges each one brings. So, what kind of challenges are we talking about? Well, first up, there's Agile and DevOps. The big challenge here is just raw speed. I mean, when you're pushing out updates daily or even hourly, those old-school slow security reviews just can't keep up. It's impossible. So the blueprint has to be baked right into those super-fast automated pipelines. You'll often hear this called DevSecOps.
Okay, then you've got the Internet of Things, IoT. The challenge here is totally different. It's about scale and constraints. How in the world do you secure millions of tiny, low-power devices? We're talking everything from your smart light bulbs to critical industrial sensors. A lot of these things just don't have the horsepower for complex encryption. So here, the blueprint has to be incredibly lightweight and super efficient.
And finally, let's talk about connected vehicles. Because this is where the stakes become literally life and death. When a software bug could potentially mess with a car's brakes or its steering, the security blueprint has to be absolutely unbelievably rigorous. There is just zero room for error.
Now, I know this might all sound like some high-level tech industry stuff, but it directly impacts the safety and privacy of the technology you and I rely on every single day. From your online banking app to the software that's running inside your car, its security all comes down to one thing. Was it built on a solid foundation?
And if you think that threat is just theoretical, I want you to look at this number. 6 times. That's the increase in reported attacks on connected vehicles in just a 3-year span. This is exactly why building security in isn't just a good idea anymore. It is an absolute necessity.
So, I'll leave you with this question to think about. As software continues to build the very world around us, I'm talking our cars, our power grid, our entire infrastructure, are we making sure those foundations are built on solid stone using this proactive security design, or are we still just running around patching cracks in structures that were built on sand? The choice we make really does determine the safety of our entire digital future.